Welcome everyone once again to a episode of Disruption Drives, and I have Elinor Doubell, who I've gotten to know over the last several months as one of the smartest people in the autonomous vehicle ecosystem. Elinor was the head of deep tech and digital innovation at BP, and had a previous stint in manufacturing at Eastman Kodak, which of course is now the poster child for not following innovation, but we'll talk to her about that. Of course, she works extensively now on deep tech low carbon solutions and is one of the foremost experts, roboticists, and technology stack generalists on autonomous car systems. So, Eleanor, welcome to the show. Thank you for
Thank you
making.
very much. Thanks for having me.
Yeah, just wanted to again. I know you're up to some new things these days, so tell us about that.
Yeah, so I, as you said, I've been leading sort of deep tech, future-facing digital R&D in BP, and this year I decided to go freelance. So I'm super interested in contributing to the whole ecosystem, but in a sort of wider way. So that's what I'll be doing. And yeah, very interested to talk to you about autonomy. Very happy to talk about Eastman Kodak. It's a super interesting use case.
Well,
And
maybe let's start there just for the sake of it. And Eastman Kodak, because every book on innovation talks about Eastman Kodak.
yes,
But I know you were there yourself, so tell us what really happened. Is there was that or
yeah,
what happened when the cell phone came out and cameras were on phones?
yeah. I joined as a grad, and when I joined, they said, "Well, there's 10 years left in silver halide photography." As in, you print using silver halide technology, not digital tech. And 10 years, I loved it. I worked in development engineering. I worked in manufacturing as a process engineer, a product engineer. Super interesting product, very complicated to make, so fascinating to make. And
So you were
started,
actually in charge of making the film, the photographic.
yeah, one of my roles was I was a product tech and I was responsible for the production runs of graphics art films, which are the films that are used by the printing and publishing industry. And one day, I looked at the manufacturing schedule, and that was my job to check everything, what was coming up, what was needed. Did we have it all planned okay? And one of my products was missing, and it was one we were, used to producing every 2 weeks. I'm like, where's 1101 gone? And like, we're not making it anymore. It's gone.
Start.
Printing has gone. What they called it was computer to plate, which meant that you didn't need all the intermediate steps that you were using film for. You just went straight from what was on the computer straight onto the printing plate, and off you go. You make your newspaper.
It's an interesting use case because now we have AI creating all sorts of stuff for us. But our
Yeah,
conversation, we should maybe talk about AI one day, but we'll do that.
yeah,
But let's talk about, well, the other
yeah. So
bigger disruption going on
yes,
in
yes.
robotics and autonomous vehicles. So now today, as we need a driver needs to pick up a car and bring it from a garage and drive it, that may not be required tomorrow. But I wanted to, Eleanor, I wanted to start with, so your background is obviously in the entire deep tech technical stack. What does what are the big components of an autonomous vehicle's technical stack? Why is it such a fancy robot?
Okay. So the first thing I would say before we get into this, to explain the type of description that I'm going to give, is I have to correct slightly on the intro. I am not a roboticist. I am what you could call a robot whisperer.
Fair enough.
So I work with the roboticists because all robots need to find their place in the world. They need to find their application, their use case. And so, because of my background in industry and practical engineering, as well as the digital side, my role is to help take the folks that have created the robots, the robot builders, and help figure out how they together we can develop those into products that are going to really work.
So you are in the commercialization of a robot. Fair enough.
Yeah,
The,
but
the
still
person
it's a
that
bit
translates the
technical.
nerds. Okay, fair enough.
Yeah, there you go. Yeah,
Right. Anyway,
yes.
talk to us about
Okay,
autonomous. But what is it?
okay.
What type of robot is that? What makes it something that can actually go on a road and not kill people?
What? Okay. So the way I would the way I'll explain this is not if you're so have you read there's a book called The Time Traveller's Guide to Restoration Britain
I have not.
by a, oh
I
by a
have
guy
not. Fair enough.
Ian Mortimer. I'm not surprised, but I'm just telling you because he does a fantastic job of describing Restoration Britain. So, just after the fire of London, time of Newton and Hooke for the physicists among the audience. And he describes it as if you're going back there, as if you're traveling in time and you're going to need all of these instructions as to how things work. How do you dress? What's the money like? What's going on? How does society work? What's going on from a science and innovation point of view, even because there was actually a lot. So I think of this as a bit like a time traveler's guide, but this is like a tech traveler's guide to autonomy. So you find yourself needing to know about autonomy, and frankly, I think we all should. So it's going to be at that kind of level. So let's think about the stack. What are we really talking about here? And how's it different from, I don't know, like a robot that's operating in a factory? So if we can think about the things this stack needs to do first, that's a good place to start. So it needs to be able to sense the world. So it needs perception, it needs to know what's around it. It needs to be able to know where it is. We call that localization. And then it needs to, crucially, make some sort of estimation as to what's going to happen next. You could call it a guess if you're being ungenerous, or you could call it a model-based prediction if you want to be more
Probabilistic
generous.
protection, right? Probabilistic.
Yeah, it's
What?
a prediction. Yeah,
Right.
it's a prediction. And then it needs to decide how to move and act safely. So it's got to be able to plan and it's got to be able to control. And then, of course, it needs to be able to talk to the rest of the world. It needs to be able to stay in sync. So it needs connectivity. Okay, so it's going to need all five of those things: perception, localization, prediction, planning and control, and connectivity.
Yeah.
And so to do that, we're going to end up with the Tech Traveler's Guide, you're going to end up with a stack which has got in it some computer hardware and the actual actuators for a vehicle. So you need the vehicle to drive, you need to be able to give it a signal and something needs to happen. You're also going to have a sensor suite. So you're going to have all sorts of different ways of telling where you are, which way you're facing, what's going on around you. So that could be radars, cameras, LiDAR, it could be GPS, it could be various other IMUs. So it could be all sorts of different sensors. So you've got your sensor suite.
And even
Then
for the damage control as well, because now the sensors are becoming so you need to have throughout the car. What if it gets a dent in some unforeseen place, right?
that's right. Suppose it gets knocked or you lose a sensor or yeah, yes. So that also talks to redundancy, doesn't it? It's sort of yep, yep. So there's all that going on in your sensor suite. And then you've got to do something with the information that's coming from those sensors. So you're going to then have a sort of a layer which is all about perception, localization, planning, and control. So all of those, it's going to take in that information. It's going to work out where is this vehicle, which is a kind of a moving robot. Well, it is a moving robot, really, isn't it?
Yeah. Yeah.
Um,
Well, hope it, well, hope it moves.
yeah, yeah, exactly. Yeah. Yes, in an ideal scenario, it's a moving robot. And then it's going to plan where it's going and it's going to control how it does that in a safe way. That's the idea. So there's that chunk of capability. And then you've of course got to connect in with the operating system of the vehicle, and you've got to take into account cybersecurity. So you've got a layer that's all about that. And then you're probably getting some nice maps from somewhere. You're probably sending out data. So you're then going to need some cloud services, and maybe you've got like a whole fleet of your cool moving robots, in which case there's maybe some back-end fleet management cleverness going on. So you're going to be connecting to all of that through cloud services. And then you've actually got the connectivity work itself. So how are you doing that? So you'll have some hardware that's going to allow you to do that too. So you've got
Interesting.
all of that going on.
Interesting. So there's lots to unpack here, but
Yeah.
let's pick on let's take a step back for a little bit. One of the core concerns, obviously, of robo taxis or any autonomous vehicles on the road is how do you know that they're road ready? They all
Mm.
have very different testing schedules, and every regulations, of course, vary by country and by state. But as a passenger or as a enthusiast, how do you know when a robo taxi is ready? How does that testing need to occur for on the
Mm.
technical side? Well, but basically as a product.
Yes, that's a fantastic question. And that really gets at how long till this kind of technology is going to be commonplace, doesn't it? That's sort of,
That was going to be my well. That was definitely
oh
going to
yes,
be my question.
yeah,
Let's
yeah,
since you asked them, let's
yeah.
combine those answers.
Yes, yes. So let me break that down because, of course, it's not straightforward in terms of standards that any autonomous vehicle would need to comply with. That the standards aren't standard and they're still developing because they're kind of having to react a little bit to the tech. So there are some great tech companies that are actually getting involved in helping set the standards and say, look, this is the way we think about the world. So maybe that gives you a good way to create some standards. And a great example of that, I won't go through all of it, but just one example is um, I think one thing it's very useful for people to know about is the concept of the operational design domain, the ODD. And this is really the physical operating space of that autonomous vehicle, or we're going to say robots. And so that really defines the space that the robot is mapping, understands, is able to update its map on, knows what's going on in that space, is able to assess threats and hazards, and is therefore in a position to, and it's probably been tested in sim as well as in real life, knows what sort of edge cases it's going to be dealing with and therefore, of course, you can never have something 100%, but over time gets a better and better idea of what it needs to do in order to navigate safely around that space, that ODD. And so that's a key question, I think, for our tech travelers is looking at, what does it take to be safe? Asking questions about, right, what is the ODD? And how do you know you can navigate safely in that ODD? What are you doing? Are you mapping it beforehand? How are you assessing risks? How are you adding edge cases when you see them? How are you trying to figure out, I don't know, you've driven it 1,000 times in the sun, but what if it's snowy? How are you doing all of those things?
And so there are competing approaches to this approach as well. There's the Tesla approach, in all fairness, that is very
Yeah.
reliant on cameras. There's the Waymo approach that is claimed it's very heavily geofenced, but
Yes.
it's intense. It requires a very high definition 3D map of a specific area that takes often
Yes.
years to
Yes.
map out.
Yes.
So what is going on in this space? What's the science behind what is theoretically necessary and feasible?
Okay, so let's put a sort of magnifying glass on localization and mapping here, because again, there's like so many different aspects to this. But if we just talk about localization and mapping, okay, so how is the robot figuring out what the map looks like of the space that it's in, and how does it know where it is? Because that's the basis for then being able to plan, isn't it? Unless you know where you are and which way you're going and what's around you, you've not got much chance. So, here there are several approaches that different companies are taking and quite often combining together in order to, first of all, get a decent map. And when I say a decent map, I mean one that's got a high enough resolution to it that you can see the level of detail you need when you're driving around. And you and I both know what that is. This can be quite detailed because you need to be able to avoid people, avoid things, and they might be moving. So you've got, for example, high density map. So let's think localization and mapping options. You could go with a high density map-based localization. So you're going to compare your sensor data to some HD map that you've maybe sucked in from the cloud, um, which has been used by all sorts of people, Aurora, Waymo, etc. So it's highly precise, and it's fine if the environment's stable. But what if it changes? You
Yeah.
then so quite often taking something like that and adding in something that allows you to then update your map, but is not too compute heavy, is then, a nice way to solve that problem. And that could be that you add in some simultaneous localization and mapping, so some SLAM. Or you go full on into the sort of next generation that some people are trying. So the sort of mapless or end-to-end learning approaches where,
Even how's that even? Well, I mean, I know there's several
and
companies claim that they have. But what is the science behind that?
Well, and I'd say compared with say some of the slam techniques, the advanced slam techniques, which are shown to work and have been being used since what, the 90s, 2000s, and still being used today. Mapless is in its early stages if we're thinking about the innovation curve. The idea here being that you take deep learning modules and you use those to predict from just raw sensor data. So you just raw sensors, and then you're
Yeah,
going to use it, yeah, the sort of almost like a black box deep learning approach, and out will pop what
right.
you need to do. Go left, go right, don't get whatever.
Hmm.
How to update your map. So the idea is it's more scalable and it's very resilient to dynamic changes in the environment because, of course, it's going on what it's got from the sensors in real time.
But you'd
But
have to define some rules, man. That would be infinite number of rules, wouldn't it?
well, this is the thing with deep learning, isn't it? The model will start to create the structure around those rules. The other issue with it, of course, is you don't know what those rules are. You don't
Right.
know what
Yeah, I
it's
mean,
setting.
it's a
So
generative
it's
AI, but you don't,
yeah,
and that's the problem.
no,
You behave in
yeah,
ways
I
that
agree. Yeah, I agree. So I really impressed and love what's been done with Slam over the last however many years. I think it's coming on really interesting journey, and it's really unlocked this space. Um, and it's kind of got its niche. It's so Slam is very good with as part of a hybrid approach. If you don't know the environments and you need to adapt in a dynamic way and you've not got much infrastructure around you, so maybe you don't have GPS, you don't have an HD map, Slam is absolutely where it's at. Um, but but if you want to do something that's less sort of compute heavy and you can update an HD map using Slam as you go. So for example, in the early days, Neuro AI based, oh, yeah, you're
no,
nodding.
no, no.
Yeah, so based in California, started off with their little delivery pods, these really cute delivery pods, but they were using a fleet of Priuses to do the mapping, and then the little pods didn't have to, carry around quite so much compute to be doing all of the
Maps,
mapping and.
but the maps were, I guess, preloaded for them.
I think that's how they were doing it. Obviously, Neuro could come and tell us a bit more if they wanted, but yes, I believe so. And it was
Now, so is Slam just to summarize a little bit what you're saying? I mean, Slam is looks like it is compute heavy if you do it real time. And now, so you're saying there's the mapless systems, on the other hand, definitely use deep learning, but you don't necessarily know how they're going to end up. Is that fair to say? So it's actually very hard. The computational intensity required to map a certain area is still a huge cost.
So yes, in terms of the relative sizes of it, I think it's almost unfair to compare because the mapless is still early days
Of
for
course.
it. So you'd have to kind of probably compare it with Slam, how it was quite a few years ago. But yes, of course, I mean, and it depends what type of Slam you're going for. Um, but it's got more computationally efficient over time. So it started off with these are just like names, doesn't people don't need to worry what they mean, but there was the original type of SLAM was called EKF SLAM, which is extended Kalman filter SLAM, and that basically set up a big matrix to say, right, I know where my robot is compared with everything, what its state, what its pose is, you'd say. And that was more computationally heavy to hold that all the time. Then it got to the next stage, which was the algorithms got a bit more efficient in the next generation, and then went to more graph-based systems. So now you're in the background instead of a matrix which is computationally heavy, you've now got this crazy graph, which is nodes and connectors, which map out almost like a brain,
Hmm.
all
There's
of the connections that you need.
very fair, very fair. Let me talk a different angle on the actual fleet itself, on the car at the end of the day, the heavy chunks of metal.
Yes.
There are approaches to this. And I know you've actually been gracious enough to share some information as well. But I did want to ask you to start off with, where are you retrofitting versus purpose-built software-defined vehicles? One of your which one's harder, which one's easier, and where's the world going?
Okay. So again, for our tech travelers, I would
A screen that I know you've
there we
talked
go.
about.
Perfect. Lovely. So do you if you suddenly find yourself taking on setting up autonomous driving, what do you need to think about? Well, I would advise our tech travelers when they're looking at retrofitting and sort of SDVs, which are software-defined vehicles, i.e., purpose-built self-driving vehicles, to think about a few things. So I am not firmly in one camp or the other. I think that a hybrid approach probably works, and you need to pick which tool depending on what the challenges you see in front of you. So, first of all, if you don't have a lot of cash, then retrofitting is going to be cheaper probably than trying to design an entire vehicle with all the hardware and the software from scratch to be autonomous. Um, Even though maybe that's where you want to get to in the end,
And just
because
to be clear, it's still we're talking multiple millions of dollars, even
yes,
the cheapest. So fair enough.
yes,
Right.
yes, that's right. I mean, do you know what? Anything to do with developing robots in physical situations, it's my experience that it costs a lot of money because you've got to your robot has got to get into the real world and you've got to figure out all the complexity of doing that. And that requires hardware as well as software and putting them together.
All right. I'll put in my notes. It requires a lot of money. All right.
There you go. Lots of cash.
Lots of cash.
Yes. Okay. Then the next thing is, if sort of linked to that, my first consideration here is what's your time to market? How quick do you need to be with this? Because if you need to go fast, using retrofitting could be really good. And what I mean here is, okay, so perhaps you've got an autonomy stack, which looks pretty good. And you want to try it for a particular use case. You want to try it, I don't know, in a shuttle bus, or transit, people transit, or you want to try it in a car or maybe in a truck, in a lorry, then rather than build from scratch, there's lots of mature tech in that space on the hardware side. There's tons of cars, there's tons of lorries. So although it might mean that the way you set it up is not optimal, it would allow you to try out your concept, maybe get to MVP, to minimum viable products, maybe even get to the point of saying, okay, how would I now set this up if I wanted to make lots of them? And try all of that stuff out. So time to market, you definitely do it quicker if there's existing hardware, in my experience. You're more constrained on the purpose-built side. Obviously, you've got to start from
Yeah.
scratch. Then long-term scale. So what's your ambition? If you are in a quite bespoke kind of application and you don't think, that you're going to get to your value without needing millions and millions of these things, then that might take you down one path. But if you're looking at, say, I don't know, passenger taxis, self-driving taxis, autonomous taxis, and you think there are going to be lots of them, then eventually you're going to want something that's production line ready, aren't you? So
Right.
something that you've designed so that it's easy to make or as easy as possible to make with the autonomy built into it already would probably make sense. Now, I'm sure there are people that are going to know of examples that contradict this or where companies have tried one and then tried the other, and that's great. That's a very interesting debate. So I'm going for this is the kind of your classic approach, your classic answer, and then the exceptions or the different things people have tried make really interesting conversations.
Yeah.
Same idea for custom user interface and ecosystem integration. I think they're fairly self-explanatory. You're in the retrofit, you're connecting in with something that's already there, so you've got the complexity of that, whereas you can design it exactly how you want in the case of an SDV. And then finally, I put it to you that there are different approaches or different places in the development cycle where each of these has its role and therefore its sweet spot. And so I would say that retrofitting, great for prototyping and testing, and when you're getting started because it doesn't cost as much and it's quicker. Um, And once you're getting into something that you want to have high volume, big strategic disruption, if you like, then that's when you could consider an SDV type approach. And I think, there are several companies that have pivoted from one to the other. I'm not sure if you can think of any that have pivoted from SDV to retro. I can certainly think of a few that have pivoted from retro to SDV, but that might be just because their tech got more mature.
Fair enough. I think Neuro, I know they had those pods, and
Yeah.
now they want to. I guess technically it's still SDV, but they have this new partnership with Lucid and
Lucid, yes, that's right.
to launch and to basically focus only on the software. So it's possible that they're expanding their market with retrofitting.
Yes, that's right. Very true. There you go. Yep,
Uh,
like it. Good
uh,
example. Very, very topical.
Absolutely, absolutely. It's an interesting point, and I'll move on to actually extremely helpful to talk about retrofitting. And are we seeing more in the market as you're seeing it? Are you
Mhm.
seeing more evidence of because software defined vehicles are very much a supply constraint at this point?
Yeah.
Are you seeing more activity in the market? Are you seeing it more on the software defined vehicles, or are you seeing the market try and retrofit vehicles more?
So I'm seeing a sort of a bit of each, but also what's interesting is a hybrid is the one in the middle. So, for example, if we're talking about self-driving privately owned cars or autonomous taxis, I think we're starting to see activity where we're seeing people partnering up.
Right, right.
So we're seeing OEMs who bring the hardware. We're seeing people like Uber who bring the platform and interface with the customer.
Yeah.
And then we're seeing, the Waymos, etc. of this world bringing the autonomy stack. And so that's where I think we're seeing exactly as you said with Neuro and Lucid, we're starting to see more activity there. That could be where it's one area where it starts to grow is these sort of partnerships with the where the hardware is more mature because it is so
Yeah.
expensive to develop the hardware from scratch.
On the final question, do you think the costs of entry for both the hardware, the autonomy part, is reducing, or is it still? I mean, of course, it's still a lot, but what elements are sort of falling? And essentially, the question is the disruption here yet, or is it still
Yeah.
very much a big incumbents play? And by incumbents, we mean like, of course, Alphabet and the Amazon ecosystem, Zoox.
Yes. Yes. So is it reducing? It's definitely reducing. I think it still needs to reduce a bit more before we can say it's set up to be ubiquitous. But that's how tech works, isn't it? We figure something out, we get it to work, and then we start to refine it. And the form factor changes, the cost point goes down. We start to solve some of the tricky edge cases that mean it's applicable in more places. And so autonomy is obviously definitely on that journey. And I would say as well, if we put the autonomy, I think a lot of people think when you say autonomy, we're talking the highest level, level 5 autonomy in cars on a public road somewhere. Okay, but that's kind of hard rules. That's like one of the most difficult things to do. There is already autonomy being used for many applications where it's already delivering value. Um, but those are maybe not so much in the public eye. And they are still not fully mature, but they're a bit more mature. So, there are working shuttles for people with
Right.
autonomy. The
Oxa is doing a lot of industrial automation work as well.
There you go. Yes, absolutely. And then you've got the truck space, where that there's a lot of progress being made there. So Einride, Aurora. So that's also an interesting space that's a bit more mature. And then of course we already have autopilots on aeroplanes. So so in terms of public transport and autonomy. It's not a completely new thing,
Yeah.
but I think we're all drawn by the case of, okay, can I get in a car and there's no one driving it and it just takes me where I want to go and it's safe. And that is I, so with tech forecasting, I think I can't remember who said this, but we tend to um we tend to overestimate how quickly the tech is going to come in the short term, and then we underestimate how quickly the tech is going to ultimately come in the long term.
Absolutely. And all that, there's a saying that says the days are long, the decades short.
Yes, there you go.
So
Perfect.
I will thank you, Eleanor. Thank you, Eleanor Doubell. Um, well, probably one of the smartest experts in the world of autonomy. I wanted to thank you for your time today. And we'll get this posted quickly enough, and hope everybody interacts and has lots of opinions on the future of autonomy.
Yes, please. Leads lots of good debate. Thank you so much, Harry. That was great fun.